So today we're going to be looking at equations that involve rational numbers. Just a reminder, rational numbers are our decimals and our fractions. They can be positive or negative. So we've talked about whole numbers and natural numbers. Those are basically all your positive whole numbers with 0. Then we talked about integers, which includes your negative whole numbers. So integers are your negatives, your positives, and 0 that are whole numbers. And then rational numbers is all of your integers, but also your fractions and your decimals, positive and negative. Now, specifically, there are decimals that are not rational, like pi. So there are going to be decimals that go on forever, and those cannot be turned into fractions. So the actual definition for rational are numbers that can be expressed as fractions. So there are decimals that you can't turn into fractions, and those are your decimals that go on forever that don't repeat. So if they go on forever and they do repeat, you can turn them to a fraction, and we've talked about that before. But if they just go on forever like pi and they don't repeat, there's no way to turn them into a fraction. So those are called irrational. So those are different. So we're just talking about rational numbers. Specifically, we're going to be looking at fractions in these equations. So we're still going to follow all our same procedures. We just have to deal with the fractions themselves, which of course is not everyone's favorite thing to do, but this will actually be easier than you may think. So when you first looked at a problem like number 5, you probably have a little moment of panic and you say, I have no idea how to do that, nor do I want to do that. So we're going to walk through it. It's actually much easier than you think. So our steps are still the same. We're going to isolate that variable. So for a second, kind of block out the denominators and just look at it as if it said 3b minus 5 equals 1. And think about what you would do. I hope everybody would get that question right. You would add the 5 from both sides, and then you would divide by the 3. So we're trying to get that b by itself. You'd get rid of the 5 first, and then you'd get rid of the 3. So we're going to do the same thing, except we're just dealing with the fractions. So the first thing we want to get rid of is this. Our final goal is to have b equals. Okay, so we want to get rid of this minus 5 halves. So we are going to add 5 halves. This is our imaginary line. You don't have to put the dots anymore. But we have to do it on both sides. So just like we do with whole numbers, we're going to do it with fractions. You're going to add 5 halves to both sides. So these cancel out. That's the whole point. So the only thing left on the left now is 3 halves b. Bring down your equals, and then you just got to do the math on this side. So it's 1 half plus 5 halves, and that's 6 halves. You could at this point turn that into a 3, whole number 3 as well, and that may even make your life easier, or you can just leave it as 6 over 2. So the last thing we want to do is we want to get rid of this 3 halves. Now, it's right next to the b, which means it's being multiplied. So to get rid of it, we need to divide. So we're dividing by 3 halves. But if you think back, how do I divide a fraction? I KFC. Keep it, flip it, and multiply, right? I'm going to flip this, and I'm going to multiply. So dividing by 3 halves to get rid of it is the same as multiplying by 2/3. Okay, so if I just had 4 over 3 and I was dividing by 1 half, we would KFC and becomes 4/3 times 2 over 1. So if I want to divide by 1 half, it's the same as timesing by 2 over 1. So if I want to divide by 3 halves to get rid of it, you could write divide by 3 halves, but what we're actually going to do is we're going to KFC. So instead of divide by 3 halves, we're going to multiply by 2/3 because I KFC'd. And you do it on both sides, of course. So take a look what would happen. Why do we do this? Ideally, or what we're really trying to do is we're trying to get a 1 as the coefficient for this b. So when you multiply 3 halves by 2/3, think about what you actually get. You can cross these out. They will cancel, but why do they cancel? If you multiplied, you do 2 times 3 and you would get a 6 on top. And if you did 3 times 2, you'd get a 6 on the bottom. And you would still have that b. Now we don't have to show this, but just for the notes today, we're going to look at it. 6 over 6 would be a 1b. And we don't write the 1, it's just a b. Okay, so that's why we're multiplying by 2/3. So we're dividing by 3/2, which is the same as multiplying by 2/3. This is called the inverse. So we're taking 3/2 and multiplying by the inverse to create a 1, which is just going to leave me with a b. So basically these cancel. Okay, we don't need to show this middle step. Now we do need to do the multiplication on this side. So 6 times 2 is 12, and 2 times 3 is 6. And we wouldn't leave this as our final answer, right? 12 over 6, you divide, and that's 2. So my final answer here is just 2. Remember we talked about right here, 6 over 2, you could have changed that to a 3, just a whole number 3, right? 6 over 2 is 3. Then you would still multiply by 2/3. So you would have took a 3 and times it by 2/3, 3 over 1, and you would end up with 6 over 3, which also equals 2. Same thing. Okay, so if you simplified early here with the 6 over 2, you'd still get the right answer. So no problems there. All right, so we're still isolating the variable, and then we simplify our answer. Now, we're going to leave our fractions as impropers. So, no mixed numbers. Your answers can be improper fractions, but we still need to simplify them. If you can divide the numerator and denominator by 2, then you need to do so. So let's slide down to number 6. Take another look. 5 was kind of easy, but they all had common denominators. If you look at 6, they don't all have common denominators. Now, you can just turn all these to common denominators right now. If you wanted to, you could rewrite this whole thing, but you'd have to look at the 4, the 3, and the 2 and figure out what denominator works for all of them. It would be 12. You could change all of them to denominators of 12, and it would work. Okay, but you don't have to do it that way. So let's just try working through this without doing that. So here's my x, right? I want to get it by itself. It's going to say x equals. So what do I need to get rid of? Well, I do need to get rid of this 3/2 and the 5/3. So you start with the one that's the lonely number by itself. So I'm going to minus 3/2. And now I need to do it on both sides. So technically I would write minus 3/2 on this side. But I'm not going to write 3/2 because on this side I've got 9/4. And remember, when we add and subtract fractions, we have to have common denominators. So while I am minusing 3/2, instead of writing 3/2, I'm going to write something that's equal to 3/2, but has a denominator of 4. So this number still needs to be 3/2 because I'm taking it from both sides. But I want it to have a denominator of 4. So if I doubled the 2 to make it a 4, I'm going to double the 3 and make it a 6. So it's going to look kind of funny because it's going to look like I'm subtracting something different on both sides, and we're not used to seeing that. But I'm actually not. These are the same numbers. 6/4 and 3/2 are the same number. So as long as I do it on both sides, I'm good. I just changed this to denominator of 4, so now that I can actually work with the numbers. Now, these negatives go with the numerators. So our answer on this side is going to have a denominator of 4, right? 9/4, 6/4, it's going to be something fourths. But I need to actually work with the numerators using these negatives. So this is negative 9 minus 6. It's negative 9 minus 6. So you got to count this negative with the 9 and subtract 6. So negative 9 minus 6 is negative 15. Be careful. A lot of people will say negative 3. It's negative 15, and you can use your calculator. All right, on this side, 3/2 has canceled, leaving me 5/3. And I'm one step away from getting an answer. I need to eliminate this 5/3. It's being multiplied times x, so I'm going to divide by 5/3. But dividing by 5/3 is the same as KFC multiplying by 3/5. So if you don't want to walk through that whole process of saying, okay, I'm going to divide, but really I need a KFC, so I'm going to flip. Instead of walking through that every single time, you can just say, if I want to get rid of a fraction coefficient, I just multiply by the inverse. Okay, so 5/3, I multiply by 3/5. Just flip it and multiply both sides by 3/5. So these are going to cancel each other out. And again, why? Because 5 times 3 would be a 15. And 5 times 3 would be a 15. So you'd end up with 1x, which is what we want. Okay, so these cancel. This side now, I'm just going to multiply straight across. Use your calculator. 3 times 15 is negative 45. And on the bottom, 5 times 4 is 20. This is my final answer. Just need to simplify it. It doesn't matter if you put x in front or not, but I do need to simplify this. I see that I can divide both of these by 5, so that's what I'm going to do. You don't have to show that, but I'm just writing it in the notes. Divide by 5 on both sides, and I'm going to get a negative 9 over 4. Now, we've also talked about a shortcut. When you get here, you can simplify diagonally. So if you see this 15 and this 5, you could actually think, well, I know I can divide these both by 5. So this becomes a 1, and this becomes a 3. And now I don't end up with this big 45 over 20. I multiply across, I get 9, and I multiply on the bottom, and I get 4. So if you see that you can simplify diagonally, go ahead and do it. It'll save you a little bit of time. But if that doesn't make any sense to you, you don't have to do it. It's not something that's mandatory to get the right answer. You can just multiply and get 45, multiply and get 20, and then simplify later. It'll work. All right, let's look at number 7. If I want to eliminate stuff from here, I'm going to start with the 1. I'm going to minus 1. So I would need to minus 1 from this side. But I'm going to be subtracting from 13 over 2. So I need something that is over 2. But it needs to be equal to a 1. I'm subtracting 1 on both sides, but I need to express it as something with a denominator of 2. So how do I express 1 as something over 2? It's 2 over 2. 2 over 2 is the same as 1. So even though both sides look different, I'm actually subtracting the same thing on both sides. This goes away. I'm left with the negative 2r. And on this side now I need to subtract. Now this is negative 13 minus 2. If you need to write it out, write it out. You don't have to. Negative 13 minus 2 is negative 15 halves. Now all I need to do is get rid of this. So this kind of looks normal, right? I'm going to divide by negative 2, but that means I need to do it on this side. Now how do I divide by negative 2 with a fraction? You KFC and you flip it. So that could get a little confusing. So if you want, put this over 1, think of it like a fraction. And remember, we're going to just flip and multiply. So I'm actually multiplying by 1/2 on both sides. Now real quick, if I multiplied a negative 2 times the 1/2, I'd get a negative answer. And I don't want that. That would get me a negative r, which then I'd have to do even more to get rid of. So what you do, if you've got a negative coefficient, is you multiply by another negative. So I'm actually going to multiply both sides by negative 1/2, so that if I did multiply these two, I get a positive 2 over 2, which is a 1r, which is what I want in the first place. Okay, on this side now, straight across, negative times the negative is a positive, so I get 15 on top, and 2 times 2 is 4. That can't be simplified. It's done. All right, last one. Here's my x. So save whatever it's attached to for last. So first thing I'm going to do is I'm going to add 3/2 to both sides. What I like about this is already a denominator of 2. So I don't need to mess with this and change it. I can just add 3/2 to it. So this is negative 5 plus 3. Well, that equals negative 2. So over here, negative 5 plus 3 gets me a negative 2 over 2. Now you could simplify that, and I would suggest that you do. Negative 2 over 2 is negative 1. Bring this down. Now it looks like a normal question that you're used to. Multiply, because this says divide by negative 2. So what am I going to do? I'm going to multiply by negative 2 to cancel it. These go away. X is equal to, negative times a negative is a positive 2. Let's say for a second that you didn't see that and you just left it as negative 2 over 2. Well, I see this. Okay, I'm dividing by negative 2, so I want to multiply by 2. So I'm multiplying, or negative 2. Since it's a fraction, though, you're going to put it over 1. So I'm actually timesing both sides by negative 2 over 1, opposite of this. Same thing I did here, multiplying by negative 2, but make it a fraction. And so then when you multiply here, you'd end up with a positive 4 on top and a 2 on the bottom, which also equals 2. Okay, so either way is perfectly fine.